Hello friends, I welcome you in lecture number 9 on complex numbers. In this lecture we are going to discuss one question asked in GTU exam about the roots of complex numbers. So if you are watching this lecture series first time, I suggest you to watch lecture number 5 and 6 to understand the methods of calculating roots of complex numbers. So let's start with this question. It is asked that find the fourth roots of -1. So first we recall that what was the formula for calculating roots of complex numbers. So if we have this z in polar form, say z equal to r into cos theta plus I sin theta, where r is nothing but absolute value of z and theta is argument of z, and of course r is positive, that is z is a non-zero complex number. Then we have seen in lecture number 5 that nth root of z is given by this formula, r to the power 1 by n cosine of theta plus 2k pi divided by n plus I sin theta plus 2k pi divided by n, and this k runs from 0, 1, 2 up to n minus 1. So there are n possible nth roots of complex number z. So to find out roots of any complex number, we must be able to find out values of r and theta, where r is absolute value of z and theta is argument of complex number z, and we will remember this formula, and by taking different values of k we will be able to find out complex roots. So in this case our complex number is -1 and we are asked to find out fourth roots of -1, that is n equal to 4 and z is -1. So first we consider z equal to -1. Let z equal to -1. We are asked to find out fourth roots of -1. So value of n is 4. Now we first find out absolute value of z, which is denoted by small r. So absolute value of z means absolute value of -1, that is nothing but absolute value of -1 plus 0 I, and we know that absolute value of x plus iy is nothing but square root of square of real part plus square of imaginary part. Here real part is -1, so -1 square, imaginary part is 0, so this is nothing but -1 square, that is 1 plus 0, so r equal to 1. So value of r is 1. Now to find out argument of -1, we have to decide the location of -1 in complex plane. Suppose this is complex plane, this is 0, and suppose -1 is somewhere here. Then we have to find out the angle made by this vector representing -1 with positive x-axis, that is this portion. This is the positive x-axis. So if we measure angle between this vector representing -1 and positive x-axis, and if we measure anti-clockwise, then this is the argument of complex number -1. So obviously this angle is pi, so argument is nothing but pi. One value of argument of -1 is nothing but pi. So we will use r equal to 1 and theta equal to pi and n equal to 4 in this formula, and if we take n equal to 4, we have 4 minus 1, that is 3. So values of k will be 0, 1, 2 and 3. So now we use that formula. Okay, we can summarize r is 1 and theta is pi, and we have n equal to 4. So if we use that formula, first we again write that formula, z raised to 1 by n is r raised to 1 by n cosine of theta plus 2k pi divided by n plus I sin theta plus 2k pi divided by n k equal to 0, 1, 2 up to n minus 1. Now we substitute all these values. So therefore n is 4, so we have z raised to 1 by 4, value of r is 1, that is 1 raised to 1 by 4 times cosine of theta is pi plus 2k pi, n is 4, so pi plus 2k pi divided by 4 plus I sin pi plus 2k pi divided by 4. And if we take n equal to 4, we have possible values of k as 0, 1, 2 and 3. So now we find out for different values of k we will have different roots. So for k equal to 0, first we find out the root corresponding to k equal to 0. So we put k equal to 0 in this equation, and we observe that 1 raised to 1 by 4 is 1, here 1 is a real number, and the root corresponding to k equal to 0 will be denoted by z suffix 0. So here 1 raised to 1 by 4 is 1, and here if we take k equal to 0, we have pi divided by 4, and same thing here. So for k equal to 0, we have cos pi by 4 plus I sin pi by 4. So cos pi by 4 plus I sin pi by 4, and we know that cos pi by 4 is 1 over root 2 and sin pi by 4 is also 1 over root 2. So this is the root corresponding to k equal to 0. This we can rewrite as 1 plus I divided by root 2. So in this way we can find out roots corresponding to k equal to 0, 1, 2 and 3. So root corresponding to k equal to 0 is 1 plus I divided by root 2. Now we take k equal to 1 again in this expression. So for k equal to 1, this is going to be 2 pi, and pi plus 2 pi, that means 3 pi by 4, and here also we have same angle. So for k equal to 1, we will have cos 3 pi by 4 plus I sin 3 pi by 4. So for k equal to 1, and root corresponding to k equal to 1 will be denoted by z suffix 1, and as we discussed, if we take k equal to 1, this angle becomes pi plus 2 pi, that is 3 pi by 4. So for k equal to 1, we have cos 3 pi by 4 plus I sin 3 pi by 4. Now 3 pi by 4 can be written as, we can replace 3 pi by 4 pi minus pi divided by 4, and this can be written as pi minus pi by 4. So we replace 3 pi by 4 by pi minus pi by 4, and we simplify. So this is now cosine of pi minus pi by 4 plus I sin pi minus pi by 4. Now pi minus pi by 4 means we are, if we have we go up to this, we have pi angle. So pi minus pi by 4 means we are in second quadrant, and we know that in second quadrant sine is positive and cosine is negative. So this is now minus cos pi by 4, and because sine is positive, sine of pi minus pi by 4 is sin pi by 4, and minus cos pi by 4 is 1 over root 2. Similarly sin pi by 4 is also 1 over root 2. So this we can rewrite as minus 1 plus I divided by root 2. So this is the root corresponding to k equal to 1. Similarly we find out root corresponding to k equal to 2. So now we substitute k equal to 2 in this expression. So if we take k equal to 2, we have pi plus if we take k equal to 2 here, we have 2 into 2, 4 pi. So 4 pi plus pi, that is 5 pi by 4. So angle will be 5 pi by 4 for k equal to 2. This is already 1. So we have root corresponding to k equal to 2 will be z2 equal to cos 5 pi by 4 plus I sin 5 pi by 4. So root corresponding to k equal to 2 is denoted by z suffix 2, and it is cosine of 5 pi by 4 plus I sin 5 pi by 4, and we can rewrite 5 pi by 4 as cosine of pi plus pi by 4. We can verify 4 pi plus pi equal to 5 pi divided by 4 plus I sin pi plus pi by 4. Now pi plus pi by 4 means we are in third quadrant, and in third quadrant tan function is positive, sine and cosine both are negative. So this is now, because cos is negative, cos pi plus pi by 4 is minus cos pi by 4, and similarly sine is also negative, so we have minus I sin pi by 4. So this is now cos pi by 4 is 1 over root 2, sin pi by 4 is also 1 over root 2. So this we can rewrite as minus, if we take negative sign outside, if we take 1 over root 2 outside, it is minus 1 plus I divided by root 2. So this is root corresponding to k equal to 2, and the last root corresponds to k equal to 3. So for k equal to 3, root will be denoted by z suffix 3, and we put k equal to 3 here. So if we put k equal to 3, we have 2 into 3, 6 pi plus pi, that is 7 pi by 4. So for k equal to 3, we have z3 equal to cosine of 7 pi by 4 plus I sin 7 pi by 4. Now we can write 7 pi by 4 as 7 pi can be written as 8 pi minus pi divided by 4, and this we can rewrite as 8 pi divided by 4, that is 2 pi minus pi by 4, or we can verify 4 into 2, 8 pi minus pi, that is 7 pi by 4. So 7 pi by 4 will be replaced by 2 pi minus pi by 4. So this we can rewrite as cosine of 2 pi minus pi by 4 plus I sin 2 pi minus pi by 4. So 2 pi minus pi by 4 means we are in fourth quadrant, and up to this we have 2 pi. So 2 pi minus pi by 4 means we are in fourth quadrant, and in fourth quadrant cosine is positive, sine is negative. So this is cosine is positive, so cos 2 pi minus pi by 4 is cos pi by 4, and sine is negative, so we have minus sine pi by 4. This is minus sine pi by 4 because in fourth quadrant sine is negative, and we substitute values of cos pi by 4 and sin pi by 4, and we have 1 minus I divided by root 2. So this is the fourth complex root corresponding to k equal to 3, 1 minus I divided by root 2. So therefore we summarize that fourth roots of minus 1 are, we write down all the fourth roots. First we write z0. Z0 is 1 plus I over root 2. So 1 plus I over root 2. Z1 is minus 1 plus I over root 2. We will write z3 here, and z4 we just find out is 1 minus I divided by root 2. And what is z3? Z3 is negative of 1 plus I over root 2, and let me check z2 also. So z3 is negative of 1 plus I over root 2. So this is z3, 1 plus I over root 2, negative of z0. and we can observe that z4 is negative of z1. If we take minus z1, we have 1 minus I over root 2. So in this way we can calculate roots of any complex number easily. We just have to remember this formula, that z raised to 1 by n or nth root of z is given by r raised to 1 by n cosine of theta plus 2k pi divided by n plus I sin theta plus 2k pi divided by n, and possible values of k are 0, 1, 2 up to n minus 1. There must be n possible values. So up to 1 to n minus 1 there are n minus 1 values, and 0, that is n values. And here r is nothing but absolute value of complex number z, and theta is nothing but argument of z. So this is all about this lecture. I hope you like it. In upcoming lectures we will be doing some more problems which were asked in university exams. Thank you very much.